So, good afternoon, students. So, in previous class, we are discussing about hypermetropia. So, about myopia, we have discussed in detail. Now, let us discuss about hypermetropia. Hypermetropia. This is called as long-sightedness, you know already. Okay? Yes. Now, what is the reason why people they'll get this hypermetropia? Hypermetropia is nothing but long-sightedness. Nana. That means the person who is suffering from hypermetropia, he can see far objects, but he cannot see the nearby objects. Okay? Yeah. Suppose if you imagine that this is a person I who is having normal view. Okay, normal view, normal person whose near point is n. Near point for the normal person will be n. Means whatever the rays which are coming from this near point, after converging from the eye lens, they will form the image on the retina. No problem. Whereas for a person who is suffering from hypermetropia eye, for that type of person, normal point is not here. It will be somewhat here. Somewhere it is receded somewhere away like this. This will be the normal point. This will be the near point from that person who is suffering from hypermetropia. Clear? That means whatever the rays which are coming from this least distance of distinct vision, for the person who is suffering from hypermetropia, its image will form behind the retina like this. Here, image will form here. Means he can't see the image very clearly. If the object is here, then this object can form the image on the retina. It will be clear. That means near point is not actual near point for a hypermetropia eye. It will be somewhat away, far away. Means it is more than 25 centimeter. Okay. Now, if you keep the object, for example, this cell phone, if you keep here, this is my eye. Let us imagine I am suffering from hypermetropia. If you want to see this cell phone, if it is here at n, I can't see. But whereas if it is here, then I can see. That means I am suffering from hypermetropia. My normal point is near point is n dash. Clear? Yes. That means whatever the objects which are located at this place or at this place, this object should be shifted to n dash so that he can see the clear image of that object. Clear? That means our aim is we have to shift this object from n to n dash. Clear? Yes. So what we can do for this is simple technique, Nana? Yes. So what we have to do is, yes, let us imagine you take this is a hypermetropia eye and it's retina. Okay. Now the near point for the defected eye is n dash, whereas actual near point is n. Let us imagine here actual near point is n. Now, if the object is here, so whatever the rays which are coming from this object, they should form its image at this n dash. Then only you can see the clear object. Okay. So for that, if you keep one more lens in front of this concave lens only, if you keep. Now, this concave lens, what is the nature of the concave lens? Will convert the rays. So instead of going like this, the rays which are going like this, they will convert somewhat like this. They will convert instead of going like this. They will convert somewhat like this. Clear? Okay. So that due to this converging effect, its image will form here. Okay. Yes. Now that means whatever the object which is placed at the actual near point will be shifted to near point of the deflected eye. So here the rays which are coming from this, they will convert to form the image on the retina, so that the defect can be rectified. Clear? That means our aim is we need to use one more converging lens of one particular focal length. What is that focal length we need to find? Clear? Yes. Now this will be the object distance for a person, u, and this will be the image distance now. This will be the image distance. Clear? Yes. Now see, this object distance is least distance of distribution that we can see. But whereas this image distance is the far point for the person. Far point. What is the far point for a defected eye? That is x. Near point for the defected eye person. Means u value we know, v value we know. Now substitute in the lens formula. What is that one? 1 by v minus 1 by u is equal to 1 by f. Okay, 1 by v. What is v now? V value is select. V value is this, and incident rays are coming from this object like this, and we should measure from optic center in opposite direction to incident ray. So this x should be taken as minus x. Okay, I am taking minus x. Minus 1 by u value. U value also because we should measure from here in this direction, opposite to incident rays. So v also should be taken as negative. So I am taking negative. Okay? Clear? Yes. So now you take it will be minus 1 by x plus 1 by d is equal to 1 by f. Take LCM x into d. It will become minus d, it will become plus x is equal to 1 by f. Then can we write the f value as f is equal to reverse x into d by x value first minus d. Clear? Yes. This will be the required focal length for a person who is suffering from hypermetropia, farsightedness. This what is x value? X value is the near point for a defected eye. This x is the near point for a defected eye. Clear? Yes. So by knowing this x value means up to what near point we can see clearly without these lenses. By knowing that we can find what type of focal length of lens we should use. How much focal length of the lens we should use. That will be x into d by x minus d. D is a fixed value, 25 centimeters. D is a fixed value, and always this x value will be more than 25 centimeters. Always it will be more than 25 centimeters. Always it will be more than 25 centimeters. Okay, so this is how we can find the focal length of a lens which is used to correct the hypermetropia. So which type of lens we need to use for correcting hypermetropia? Convex lens we should use. Okay, remember these points now. Remember these points. Okay, yes. Now, so we discussed two types of defects now. Now, third type of defect is presbyopia. What is that, Anna? Third type of defect is presbyopia. Okay. So, what is this defect? This defect is due to aging of a person. Anna. With increase in aging, the ciliary muscles which are having that which will expand and compress that eye lens. The ciliary muscles. Yes, here. This is the lens, and this lens will be held in this position with the help of ciliary muscles. With the help of ciliary muscles, it will be held in this position like this. Okay, these ciliary muscles, they can, depending upon the situation, if a person is seeing far objects, they will get relaxed. If a person is seeing very nearby object, they will get compressed. So this ciliary muscles action, elastic nature of the ciliary muscles will be decreases with the aging of the person. Okay, due to that accommodation process, means increasing and decreasing of the focal length of the eye lens cannot be happened properly. So that person cannot see a clear image. Far objects he can't see, nearby objects also he can't see. So that type of defect will be called as presbyopia. So presbyopia is due to main factor is due to aging. Aged person, maximum it will be for aged persons now. Okay, and how we can correct this type of defects? This type of defect, presbyopia defect, can be corrected by using bifocal length. Till now, for myopia, concave lens focal length we have using. Whereas for hypermetropia, convex lens we are using. Whereas for correcting this presbyopia defect, we need to use bifocal length lenses. Two focal lengths should be there. It should correct the hypermetropia, it should correct the myopia, both. Means both, concave lens, convex lens, both will be included in a spectacles. The type of lens we should use to correct the presbyopia. Here? Yes. Now, next fourth type of defect is astigmatism. Fourth type of defect is astigmatism. Hey. Fourth type of defect is astigmatism. Astigmatism is nothing but a person who is suffering from this type of defect. For this type of defected eye, see for example here, one vertical line is there like this. Then the person who is suffering from this defect, astigmatism, he can see image maybe like this or like this. Zigzag. He can't see the clear image. Okay? Or else, for example, if there is a mesh like this, there is a mesh object is a mesh like this is there. Then he can see only image, he can see only this horizontal lines. Or he can see only vertical lines. He can't see this mesh shape. That type of defect is called as astigmatism. The main reason for the astigmatism is here in front of this lens, there is a cornea will be there, no? Like this, cornea will be there, no? Cornea will be there. Okay, this cornea, it doesn't have a proper radius of curvature. Due to this reason, a person can see this type of images. Okay, and the colors also he can't differentiate. We can't see clearly the different colors. See, on my shirt checks are there. No, this shirt checks he cannot identify the person who is suffering from this astigmatism. Okay, the reason for that is what? The improper radius of curvature of the cornea. That is the main reason. And how can we correct this astigmatism? We can correct this astigmatism by using cylindrical lenses. Cylindrical lenses. By using cylindrical lenses. Cylindrical lens. By using cylindrical lens, we can correct the astigmatism. Okay? Yes. These are the four different types of the defects and how we can correct them. Okay? Mainly you have to remember myopia and hypermetropia. For myopia, which type of lens we should use? Concave lens we should use. Okay, so for myopia, for correcting myopia, we should use concave lens of focal length f is equal to minus x. X is the far point distance. Up to what maximum distance you cannot see that distance. Okay, and for hypermetropia, we should use convex lens of focal length x into d by x minus d. This is the focal length that we need to use for correcting hypermetropia. Here what is x? X is the near point for the hypermetropia eye. Here x is the far point for a hypermetropic eye. That you need to remember. Okay? Clear? These are the formulas. You must remember these two. Clear? For calculating. Okay. Now let us go to another topic of this chapter, and it is a very important topic. That is simple microscope. Yes, I write from here. Simple microscope. Yes. So what is a simple microscope? Simple microscope is nothing but it is a device which can magnify the image. Clear? Yeah. So what is the condition for simple microscope? And simple microscope condition is nothing but see here like this. Let us imagine this is a lens and this is the optic center for the lens. See, this is the optic center, and the line which is passing through the optic center is called as principal axis. Now let us imagine here two focuses will be there. No, here focal length, here focal length. Okay, here to here and here are the double to here. Okay, this will be the principal focus. This is the secondary focus. Okay. Yes. Now for magnifying image, where we should keep the object? If we keep the object here like this. If we keep the object here between focus and optic center of a lens, then what type of image will form? How image will form? First, ray which is passing through the principal axis after refraction passes through the focus. Ray which is parallel to the principal axis after refraction passes through the focus. Next, one more ray we take which is passing through the optic center. After refraction, it will pass undeviated like this. So if you see these two rays are diverging away, means they cannot meet at infinity. Now for their intersection, what we need to do? You take these two rays in extended rays in backward direction like this. These two rays extend them in backward direction. Somewhere else they will meet. Somewhere they will meet. Okay, yes. Let us imagine here they are meeting. Yes. Okay, yes, here they are meeting. A dash, B dash is the image. We are getting clear. Now, this is the image which is erect, magnified, and virtual image it is. Okay, yes, in simple microscope, always image will be erected, virtual, and magnified image. Okay, yes. Now, your eye level will be here. Means you are seeing from this point. We are seeing and seeing this object. Clear? Yes. Now, how much it is magnified? So that magnification can be defined by using angle, how much angle these rays can sustain at this eye. Our eye will be exactly here. Exactly, eye level will be here. It should be eye level. Okay. Now, with the eye, this image and object, how much the angle they are making? That angle we need to measure. Clear? Yes. Now here, see, the image is making an angle of beta. Image is making an angle of beta with the eye. Eye level is this principal axis is eye level I am taking. Image is making an angle of beta with the eye. Clear? Yes. Now, object. Now, if you see from here, you can't see the object now. Because if the object is less than the least distance of distinct vision, you can't see it clearly. So for that reason, you need to take this object to your least distance of distinct vision. Let us imagine your least distance of distinct vision is here. Means if you take the object exactly here, I am saying that let us imagine it is your least distance of distinct vision. Okay? Yes. So this will be AB image object. Okay, AB. I am bringing this object to this point. On the image I am bringing so that I can see the object also clearly. Are you understanding what I am saying? Let us suppose that you have adjusted this lens so that image is forming at least distance of distinct vision to your eye. Now, to see this object, you need to shift this location of the object also to the least distance of distinct vision. Clear? Yes. Now, this is the object AB. Now, this is A dash B is also object now. This is object now. Now, this object, it is also makes some angle with the eye. That angle, let us call it as alpha. Here? Yes. Now, magnification of a single microscope we will define like this. Angle subtended by the image at the eye to the angle subtended by the object at the eye when both are located at least distance of distinct vision. When both object and image are at least distance of distinct vision, then how much angle image will make beta to how much angle object will make alpha. That ratio we call it as magnification. Okay, this magnification are also called as angular magnification because we are defining in terms of angles now. So that's why it is also called as angular magnification. So what is angular magnification? They may ask you for a definition for your board exam. What is angular magnification? Angular magnification is the ratio between angle subtended by the image at the eye to angle subtended by the object at the eye. When condition is when both are at the located at a least distance of distinct vision. Yes, this is the condition and this is the definition for the magnification. Clear? I hope you are understanding what I am saying. What is the magnification for a simple microscope? ratio. It is also called as angular magnification. Is ratio between angle subtended by the image to angle subtended by the object. Alpha is the angle subtended by the object. A dash B is the object because AB height, A dash B height both are same. I am taking. Just I am shifting it to A image position because image position is least distance of distinct vision for me, so I can see the object when the object is at least distance of distinct vision. That is the reason why I am shifting this. Otherwise, no need to be shift. Okay? Yeah. Now, since if the angles are very small, let us imagine these rays are paraxial rays. If the angles are very small, then this magnification can also be defined as tan beta upon tan alpha. Can be? Yes, definitely. Why not? Clear? So magnification can also be defined as tan beta by tan alpha. Clear? Yes, magnification is equal to beta upon alpha. Yes, okay. Now let us find what is this beta and alpha. Tan beta and tan alpha. What are this? Beta and alpha. Let us find. But tan beta is what now? So for this tan beta, what is this angle? Let us find this. Clear? Yes. Now beta angle can be defined by this is opposite side, this is adjacent side. Clear? Okay. For this beta, opposite side is A dash B dash and adjacent side is C A dash. Clear enough? Okay. 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 For this beta angle, opposite side is A dash B dash and adjacent side is C dash. Whereas for alpha angle, opposite side dash A dash B and adjacent side is for alpha angle. This is AB. Okay, alpha angle, this is this. AC, CA, this is angle subtended by the object here. Okay, yeah, I am writing here first. Okay, tan beta is this is the beta angle. This angle is beta, total angle. This total angle is beta. See, this angle is also equal to this angle. Right? Okay. Yes, this angle, both are same. Is it correct what I am writing? Yes. So instead of taking A dash B dash, I take AB. Because these angles are same, no? Clear? Yes. So I am taking AB. Tan beta is AB upon adjacent side for this is what na? A dash B dash is opposite. Adjacent side is C A dash. Okay? Yes. C A dash upon tan alpha. For this alpha is A dash B upon this distance is alpha, no? Yes, C A dash. Okay? Yeah. So this is CA na. CA. This is C. This is beta na. Opposite side by adjacent side. This beta you take this only. Why not? Why this? Beta you take this. Because this triangle, yes, I am feeling. This triangle and this triangle. Both are similar. Okay? So opposite side by adjacent side. AB by CA. AB by CA. And for alpha, A dash B by C A dash. Yes, I have written. And you know that AB and A dash B both are same height wise. So delta AB and A dash B are same. Now what will happen? Magnification will become C A dash will go up upon CA. Correct? Yes. What is CA dash? CA dash. Optic center to A dash is image distance. How much it is? Capital D. How much it is? Capital D. So I am writing capital D. Upon CA, C to A. What is this now? Object distance U. Where we have kept this object is D. Yes. If we take with the sign convention, incident rays are going like this, and we should measure in opposite direction like this. Means D should be taken as negative, and U also we should measure like this. It is also taken as negative. Negative cancel, so that we get D by U. This is the magnification. Du value you know. 25 centimeters. U value only we need to find. Sometimes we don't know where we are giving shift. Just we will change this location of the lens line. So where we are giving this object exactly we don't know. So for that we have another formula also. I'll show you first. First you tell me whether you have understand this d by u. How I came to this point d by u. Did you understand this point? I want that only. If you will not understand, there is no use. Did you understand enough how I came to this d by u point? Magnification. Actually it is v by u. V is d distance. Image where it is forming at a d distance. Least distance of distributor. So that's why d it is. Students, I want one message from you that whether you are understanding or this point or not. Yes. Vivek is saying that yes sir. Okay, no problem. Yeah. Now, so I got the point as magnification is d by u. Clear? No. Here there is no confusion. No. This here only. I think so. Students will get confused. Why I have taken AB by CA? This is angle. This is nothing but this is also. So that's why AB by CA I have taken tan beta. And AB I have taken here. It will become A dash B dash. A dash B dash by CA dash will become angle alpha, tan alpha. Okay? Yes. Now, so magnification I got the value as magnification m is equal to d by u. Okay, sir, no problem. But u value is unknown. If u value is given in problem, we can find the answer very easily. But u value they won't give you. They will give you the focal length of this lens. Then what to do? Yes, formula is 1 by b minus 1 by u is equal to what? 1 by f. Correct? Yes. Now, see, I want d by u, no? I want d by u, no? Yes. Now, see, this total value divide with, multiply with v. What will it? V by v minus v by u is equal to v by f. Correct? Yes. This is 1. 1 minus v by u is equal to v by f. Then what is v by u, Nana? This is nothing but 1 minus v by f. Correct? Yes. So this v by u is nothing but v is image distance. Where this image is forming? V is equal to v. So v is equal to means d by u. Yes, d by u is equal to 1 minus v value is d by f. Minus sign we should be. So you will get magnification is 1 plus d by f. This is the formula for the magnification. Okay na? So this will go that side, this will come this side. It will become 1 minus v by f. V is because object is we are measuring like this and image should be measured like this. So that's why I am using negative of minus d. So it will become plus d. 1 plus d by f. So when you know the focal length of the lens, you can find the magnification. Formula magnification formula is 1 plus d by f. Yes. D value is known value, fixed value, and f value also they will give you. They will mention how much magnification we can produce. Magnification we can produce is equal to 1 plus d by f. Clear? This is the formula when image is formed at a least distance of distinct vision. This is the condition I have taken when the image is forming at a least distance of distinct vision. But if the image forms at infinity, in this condition, when image forms at a least distance of distinct vision, your eye will be strained. You will get some pain on your eye. You can't see continuously that image because your image or object where whatever it is forming, it is exactly at least distance of distinct vision. It means this much distance. This much distance object you can't see for a long time. It will strain your eye. Okay, so that's why we will not always we will not prefer to see this much magnified image. So we will prefer what relaxed eye. We should be relaxed. We should not get any pain on our eye, so that we should get a magnified image. So for that, what we should do? The image should form at infinity. Then only eye will be relaxed. without any strain. So for that, what we need to do, this object shift to the focus. Image will form at infinity. This is the thing. Okay? Yes. Let us discuss that point also. This is the formula for when image forms at the least distance of distinct vision. Now, let us take the object exactly at focus. Yeah. So where its image will form, Nana? Its image will form at infinity. Yes or no? Yes. Its image will form at infinity. How it will form? It will be like this. When object is at infinity, when object is at focus, virtual and errant image will form at infinity. At infinity it will form. Clear? Okay? Yes. Now, this object AB, how much distance it is making? So this object U will be nothing but F. No. U will be nothing but F. U will become F. Whereas image is forming at infinity, it will be relaxed now. Clear? Now, for that magnification formula will become D by U. What is U, Nana? U value is focal length. Because object we are keeping at focus, then only image will form at infinity. No. So U value will become F. So it will become D by F. So magnification formula when image forms at infinity is D by F. Whereas when image forms at least distance of distinct vision is 1 plus D by F. Now, in which case magnification will be more? In this case, when image forms at a least distance of distinct vision, magnification will be more one time. Then image forms at infinity. Though its magnification is more, it will strain our eye. So it is not fair to use this much magnification always. So we will prefer to see this much magnification only always. How much it is? D by F. F value they mentioned. Clear? Okay? I hope you are understanding. Just directly I have substituted U value how much? F. Why? Because image should form at infinity. When it will form? When object is at focal length, image will form at infinity. So magnification in the case of U, there will be substitute F. Will get D by F. Formula you get magnification is D by F when image forms at infinity. This is image forms at least distance of distinction formula. Okay, one magnification, one value more in this case. Here, one value will be less. So, for suppose if I use the lens is like this, simple microscope. I am using. I am trying to magnify the image. Okay. Yes. The lens is given for us, and the lens of focal length is 5 centimeters given. Okay, what is this magnification? How much magnified image we will get? Let us imagine it is acting like a simple microscope. How much magnification you will get? You will get two magnifications. One magnification is 1 plus D by F. Means 1 plus 25 by 5. This is in centimeter, this is also centimeters. 5 ones are 5 fives are. Means 6. Magnification is 6. Means object is some 2 meters, image will be 6 times of 2 meters, means 12 meter magnified. But this will strain your eye. You can't see this 6 times of the image for a long time. Another magnification you are having. Another magnification is D by F directly. That is 25 centimeters by 5 centimeters. You get 5 magnification will be 5 times. Means 2 meters height object if you use, if you want to see, it will become 10 meters height, virtual image only. Clear? And which magnified image we can see for a long time? This magnified image. Clear? Okay? I hope you are understanding what I am saying. This differentiation, simple point. Clear? So simple microscope, what is the condition for the formation of image, Nana? The object should be between focus and the optic center. Then only image will be erect, virtual and magnified. How much magnified it is? Magnification due to a simple microscope will be D upon U. Okay? Yes. Now that formula also can be written as 1 plus D by F. 1 plus D by F. When image forms at infinity, then the magnification will become D by F. Magnification will become D by F. Okay? These are the 2 points. Okay? Clear? Yes. Now, in next class, we will discuss about compound microscope, and it is very important for your board exams. Okay, important. Compound microscope is important. In next class, we will discuss about the compound microscope. Okay, yes. Bye.